All right, let's do this problem called find minimum in rotated sorted array. So essentially the array was sorted, then it got rotated, and in that rotated array, you have to find the minimum. And whatever is the minimum, we have to return that. All right, so let's switch to a whiteboard. Let's take the example input. So the example input is 3, 4, 5, and then 1, and then 2, and obviously 1 is the minimum. And the original array obviously was 1, 2, 3, 4, 5, and then it got rotated and became 3, 4, 5, 1, 2. Now, what is the how to find the so let's first look at how the rotated array looks like, right? Um, so if you were to if you were to maybe like a plot it something like this. Let's call this as 1, this as 2, this as 3, this is 4, and this is 5. Then it looks like it starts with 3, then goes to 4, then goes to 5, then it drops to 1, then it goes to 2. This is how the graph looks like, right? Now, essentially, and the original graph, I also brought the original graph. The original graph was 1, 2, 3, 4, 5, like straight line, but that was the original graph. And on rotation, this is how it became. So essentially, if you look at the rotated graph, this is the minimum point, right? And that is the only point in the graph whose left and right both are greater than it, right? If you look at this guy, okay, this is the end point, fine, this is the end point, fine. But this guy, if you look at it, left is smaller, right is greater. This guy, if you look at it, this is the maximum guy. So both left and right are smaller. This is the minimum guy where the left and right both are greater, and this is the end point. So essentially, if in the rotated sorted array, the minimum for minimum, both left and right are greater, right? That is the way to find. And the other bit is if you're looking at max, in which case this is the max. For max, both uh, left and right are smaller. For everyone else, it would be left is smaller and right is greater, right? Now, like in, however, there is one case which is if the array was rotated n times and it ended up being in this way. Well, then you figure out if the array is completely sorted, in which case the leftmost array is the leftmost point is the minimum, the rightmost point is the maximum. So how do we figure that out? So essentially, your array's shape. Oops. So essentially, uh, what happens is your array shape is something like this. It increases, right? And then at some point it decreases, and then it again increases back. Like that is how your array looks like, right? So now what you're going to do is you're going to divide the array into two parts, and there will be two cases. Like if the array is actually rotated with 0 to n minus 1, then you will have one part which is sorted and the other part which is not sorted. And the other part which is not sorted is the one which will have your maximum and the minimum, right? And we'll find the minimum. Now, if both parts were sorted, then that would have been the case for the array rotated n times. And if you find out that the both parts are sorted, then that means the array is sorted, and you just take this guy uh, as the minimum. So based on this logic, let's try and build the code. So first thing first, if the okay, so let's do L as 0 and r as nums.length minus 1, and while l is less than equals to r. Handle basic case within this while loop. First is which is if L and R are equal, that means there is a single element and that single element has to be the minimum. So just return nums of L. Let's also handle two elements. So if R equals to L plus 1, that means there are two elements only, and in those two elements we just do whichever is the minimum. So return math dot min nums of L comma nums of R. And now we have at least three elements, right? So let's first find the mid. So we find the mid, and now we check. First of all, we check whether mid is the answer, and the way if mid would be the answer would if uh, nums of mid minus 1 is also greater than nums of mid, and nums of mid plus 1 is also greater than nums of mid, right? Then that means this guy is the minimum. So you return nums of mid. Otherwise, what you do? You check which part is sorted. So let's define this. Boolean is left sorted, and that would be left would be sorted if nums of L will be less than equals to nums of mid, and is right sorted. You can do nums of R is greater than equals to nums of mid, right? Now one of them will not be sorted, or if both are sorted, that means the entire array is sorted. So is left sorted and then is right sorted. That means the entire array is sorted, in which case return nums of L, as that has to be the minimum. Else if the left part is sorted, then the minimum will be in the right part. So minimum in the right part means you do L equals to mid plus 1. Otherwise, the minimum will be in the left part, so you do R equals to min minus 1. And we should be returning something from it, but just for the compilation purpose, outside this while loop, let's just return some maybe nums of 0, and then run. And submit. And it works. All right.